So I'll be attempting an IGCSE vector question, which kind of troubles a lot of students. So the vector topic kind of troubles a lot of students. So the thing I do usually is just label everything on the diagram. So that's what we'll start off with. So OA is 4A. And then OB, as you know, is 4B. Then we'll move on to this. So as you know, AC is equal to 2OA. So as you know, OA is 4A. And then AC equals to 2 times OA. So therefore this equals to 2 times 4A, which equals to 8A. So we'll just write 8A over here. Then BQ and QC are in the ratio 1 to 3. So so BQ and QC are 1 to 3, right? Okay. So actually, we'll just start off with doing B. We'll find BC first. So we'll just find BC, right? So as you know, BC. So BC, that is equal to OC minus OB. Okay. So first it goes in the so BC is basically BO and then C. So as we know, OB is 4B. So to get BO, we need to do negative 4B. So BO and then OC, which is in the upward direction, OC. So which is in the direction of BC. So BC is in the upward direction, right? So we need to go BO, OC. So we'll just do that. So BC equals to OC. OC we know is 4A plus 8A. And then OB is minus 4B. So you know, this is 12A minus 4B. So that is BC. Okay, we know this. Then we can further label the sides. So as we know, BQ and QC are in the ratio 1 to 3, right? So BQ equal to 1 over 4 of BC. And QC is equal to 3 over 4 of BC. Okay. So therefore, BQ equal to 1 over 4, 12A minus 4B, which is equal to 3A minus B. Right? And then now we know, then we can do QC, which is equal to 3 over 4, 12A minus 4B. Okay? And then that is equal to so 9A minus 3B. So we know this. Okay? So now we know BQ and QC. So BQ, we know it is 3A minus B, and then QC is 9A minus 3B. The reason I'm labeling all the sides firstly is because it gets easier later on to solve the more harder problems, the more harder parts of the question. So now we'll start with II, okay? So which is AQ. Okay, we did this, now we did this. Okay, so AQ. So we need to find AQ. So AQ, we can do it by just, so as I said, see, in this AQ we need to know QC, but as we already found QC, it just makes it so much more easier for us, you know. If you just label all the sides, it's easier because you don't have to keep finding them again and again. Okay, so we know AQ. So AQ, it's in this direction. So we can just go from A to C and then C to Q. So from A to C, that is just 8A in the upward direction. But then we know QC, Q to C, which is 9A minus 3B. So we need to multiply it by negative 1. So negative times 9A minus 3B. Subtract it, basically. So then that is 8A minus 9A plus 3B. And then, which is negative A plus 3B. So we know AQ as well. Yes. I hope it's correct. Okay, so now we have BC and we have AQ. Okay, so now we'll move on to the next part of the question, which is part B. So we need to show that AQ and X are a straight line. Because that's what we have to show. Right. So, okay. So we need to show that AQ and X is a straight line, right? So one way we can show this is basically by basically we need to prove that QX is a scalar of AQ, right? So we'll just do it that way, right? So we need to find AQ, and we need to find QX in AQ, and then we need to find and we basically need to find QX. Basically, that's the main goal of what we have to do. So as given in the, so we'll just draw a line over here. So our main goal, let me repeat it again, is to show that QX is a scalar, some constant scalar of AQ. So this needs to be a scalar. So it's a key term. It has to be a scalar. It has to be a multiple, in other words, of AQ. So that's what we have to find. So now we have a statement using this one. So we know, let's assume that QX equals to a scalar of AQ. So this is some Greek symbol which I don't know how to say. I'll just say it's something. So it's a scalar of AQ. Right. So then we have a statement. Okay. And then we'll just do Q. As we know, AQ is negative A plus 3B. We can just substitute that in. So we know QX is negative A plus 3B. So we know that QX is negative A plus 3, this symbol B. This is what we have here. We know this is QX, okay? We're just assuming at this point, okay? And then now we know that from the question, we know that BX equals to 8B. And we know OB equals to 4B from the question again. So therefore, we know OX is equal to 4B plus 8B, which is equal to 12B. So we know this. So we know that is equal to 12B. Okay? And now, using the same ideology, we can do that AX is equal to AQ plus AQ plus AQ plus QX. So therefore that equals to negative A plus 3B plus negative plus 3 plus B. Okay. So that's negative A plus 3B minus the symbol A plus the symbol 3 times the symbol B. So now we'll have to factorize it or whatever. So we get we can do negative A minus this A plus 3B plus 3 this B, and then we can factorize A out, so that's negative 1 minus this A. Okay, and then we can factorize B out from here, so we get 3 plus 3 this B. So you get AX. Okay. Now we need to find. So now we have AX, and now we have OX. So we have OX, and we have AX over here. Okay. Okay. So now we need to clear out and get some real estate, as Khan Academy says. So we'll just clear this space out. Okay. and then we'll just write our things down. Okay, so we just draw a line over here. Okay, so now we know that ax equal to -1 minus a plus 3 plus 3, the symbol b, and we know ox equal to 12b. So we know these things. Okay, so yeah, okay, now we know these things. Okay, so and then as you can see in our diagram, we know that 4a, so we know that as you can see in the diagram, we know that OA plus AX equals to OX. Okay, this is a vector thing. So OA plus AX equals to OX. So it goes here, and then it goes here, and that is equal to OX. So it goes here. Okay, so yeah. So as you know, OA is 4A, and AX is -1 minus this A plus 3 Dorito B, and then OX is just 12B. So and then we can factorize the A thing again. So we get 4 minus 1 minus this Dorito A plus 3 Dorito B equals to 12B. So you get 3 minus this Dorito A plus 3 Dorito B equals to 12B. So now if you make some kind of modification on this side, so we'll do 3 minus Dorito A plus 3 times Dorito B equals to 0 bracket A plus 12B. So this is a very, so we're just doing 0 times A because it just makes something easier. So I'll just explain this very important fact in derivatives for you. So in derivatives, sorry, not derivatives, so in vectors, the coefficient of A on the other side of the equal sign, on the left hand side, is equal to the coefficient of A on the other side, so on the right hand side, so and vice versa. So coefficient of A on the left hand side is equal to the coefficient of A on the right hand side. So these two are equal, and the same goes for B, or any other or any other vector in the question. Okay, so the coefficient of the same variable on each side is always equal. So this is equal to this. More algebraically, this is 3 minus Dorito equals to 0, and 3 plus 3 Dorito equals to 12. Right. We don't need to solve this because it's just overly complicated. We can just do this, right? So this is just a 0 equals 3 minus this. So therefore, Dorito equals 3. And this applies for this also, because if you plug in 3 over here, you still get 12, okay? So now we get Dorito equals to 3, okay? So as we can see right now, let me clear out a little bit more of real estate. As you can see right now from this, as we know, Dorito equals to 3. Therefore, Q of X is equal to 3 of AQ. As he stated over here, at the right hand side of the page, as you can see over here, Q of X is equal to the Dorito times AQ. But and as Q of X equals to Dorito times AQ, and as we know that the Dorito is equal to 3, we know that Q of X is equal to 3 times AQ. Okay, so hence Q of X is a scalar of AQ, and this statement is important. You have to state this in order to get full marks. So the scale of AQ, therefore AQX is a straight line. Okay, this is the concluding statement. You have to state it, and then if you want, you can write QED or just something in Latin. I say it's quite easily done.